Hello everyone. Okay, so what are we going to do in this video? So what we're going to do is we're going to review a couple of rules that you learn under basic integration in your Calc 1 or pre-calculus classes, but really we need them in calculus 2. Okay, but these rules are very easy, and also I'm going to show you one of the very common mistakes that you do while you're solving integration problems. Okay, so let's get started, right? All right, what is the rule number one? So the rule number one is how to integrate a constant. Hopefully you know this already very well, but let's review it very quickly. Okay, so k is a constant here. You need to integrate a constant. So what is a constant? A positive number, negative number, a fraction, a decimal, any real number. Okay, all right. So what happens when you integrate a constant is, according to the rule, you get constant times x plus that c is an arbitrary constant. So let's do an example. So if you want to integrate 3 with respect to x, okay, so x is the variable, what you get according to the rule is 3 times x plus c is the arbitrary constant. Now don't forget that arbitrary constant. Okay, so this is just a review. All right, okay, now let's integrate a negative number. How about negative 2? If you integrate a negative number, the rule is same. It's going to be negative 2 times x plus c. That c is again the arbitrary constant. Okay, how about if I integrate a fraction? Well, is fraction a constant? Of course, yes, right? So let's integrate half. What do you get? Half times x plus arbitrary constant c. So that's pretty easy, right? Okay. Now let's move on and learn rule number 2. Okay, so you want to integrate x to the power n with respect to x. Now n is again a number. It can be a positive number, negative number, a fraction, a decimal, anything. Okay. Now according to this rule, what it says is what happens. You add 1 to the power. So you have n plus 1 and you divide by n plus 1, and of course you have plus c, the arbitrary constant. So let's see. Again, it's a very easy rule that I think you all know. So if you want to integrate x cube, for example, what happens is the n is 3. So you get 3 plus 1 over 3 plus 1 plus arbitrary constant c. So this is x to the power 4 over 4 plus c. Okay. All right. So let's do this for a negative number. Okay. Now, how do you do it for a negative number? X to the power negative 3. You integrate with respect to x. Now, what happens is, well, x to the negative 3 plus 1. Again, the rule is same. Divide by negative 3 plus 1 plus c is the arbitrary constant. Now, I wanna simplify this furthermore. Okay. What can we do? So, negative 3 plus 1 is negative 2. Divide by negative 2 plus c. Okay. Now let's see, we can bring this negative to here up front to the everything. So here we can put that negative there, x to the negative 2. So this will be just 2. Okay, let's do one more thing. Now I want to bring that x to the negative 2 to the denominator. Now right now it's in the numerator, of course. How can you do that? Well, when you bring that x to the negative 2 term, this term to the denominator, what happens is this sign in the power, it's negative, it's gonna switch to positive, right? So that is basic power rules, something that you need a lot in calculus too, something that you need a lot in any math class, right? So minus 1 over 2 times x squared, right, plus c. Now this is a better version of our initial answer. So this is what you get after you integrate x to the negative 3. Okay, right. Now what is the common mistake that you do often? Well, this rule is not valid when the power is negative 1. As you can see, I have stated n cannot be equal to negative 1. Now what does that mean? Why is that? Well, let's see it for ourselves. Okay, so let's integrate. In fact, let's try to use the rule. Let's try to break the rule. Okay, all right, so I'm going to use the rule x minus 1 plus 1 divided by minus 1 plus 1 plus c. Don't forget the c. So negative 1 plus 1 is 0, so x to the 0, nothing wrong there, right? X to the 0 is just 1. Okay. Divide by negative 1 plus 1 is 0. Now do you see a problem? Can we do this? Can we divide by 0? No, mathematically it's not defined. It's not correct mathematically. You can't divide by 0. That is why this rule doesn't work when you have the power as negative 1. Alright? So don't use this power. You don't use this rule, not the power actually. Don't use this rule when the power is negative 1. You might get panic, you might use the rule and get panic and write something else. Sometimes in like exam you might write like negative 2 or something else, who knows. But remember this, okay? Think it a little bit before you use it, okay? This is one of the most famous mistakes that you can see in exams or homeworks that you do. All right, now before I finish off this video, now you might have a question, well then how do we integrate x to the negative 1 with respect to x? Well, that we are going to discuss in a future video because we have a separate rule for that, okay? All right, now one more thing, one more rule. Actually it's not a rule. Well, how about if your power is a fraction? How about then? Well, it's again the same rule, okay? But you have to be a little bit careful. Let's say you have to integrate x to the power half with respect to x. Now what is the rule? You add a 1 to the power and divide by that number you get after you adding 1. So x to the half plus 1 divide by half plus 1 plus arbitrary constant c. Now students can do a mistake here also. Now what is half plus 1? This I suppose you all know. So this is actually 3 over 2, right? If you use the common denominator as 2. Okay, so this is x to the power 3 over 2 on the top. Now on the bottom also it's actually half plus 1, 3 over 2. Now rather than leaving our answer like this, we can write it in a nicer way. I think you have to write it in a nicer way. How? Well, we are going to do something with this 3 over 2. How can we rewrite it in a better version where in the main denominator, like here, how can we not have a fraction? Right now we have a fraction 3 over 2. How can we not have a fraction? How can we get rid of that fraction? Well, what does this whole thing means? Now this is a useful tool that we need in calculus too, okay? So you have x to the power 3 over 2. You have to divide it by 3 over 2, right? So that is what this denominator means here, this fraction means here, right? So you have to divide by 3 over 2. Well, division is same as reciprocal multiplication. So you can, instead of division, you can multiply by 2 over 3. You take the reciprocal of the denominator that you had here, okay? You do the reciprocal here. So actually this is 2x to the 3 over 2 over 3 plus arbitrary constant c. Now this is very important. This is a very, very important skill, okay? When you have division, you take the reciprocal and write it in a different way. So this is the answer that you would want to write, you would want to use when they ask you to integrate x to the power half or any fraction, okay? This is the procedure that you should take when you have a fraction as a power. All right, so let's do one more example, okay? How about an example where we have a negative number, x to the negative 1 over 3 with respect to x. Now the same rule, be careful, negative 1 over 3 plus 1 divided by negative 1 over 3 plus 1 plus arbitrary constant c. Now negative 1 over 3 plus 1, well, we can multiply this 1 by 3 over 3, right? Okay, that's the common denominator. Common denominator is 3. So actually this is 2 over 3. So here you have x to the 2 over 3, right? Divide by 2 over 3 plus c. All right, so let's use that reciprocal trick here. So this can be written x to the 2 over 3. Now divide by 2 over 3 can be written as 3 multiplied by 3 over 2. So this is the answer you would want to write. Try to do this slowly if you're not familiar with that or if you're not comfortable with that reciprocal simplification. Okay, so I am going to see you in the next video. In the meantime, please click the link here to watch my next video to learn what are the other rules that you have to know before you take calculus 2. So I will see you in the next one. Bye bye.